Good afternoon, my name's Matt and I'm here to talk about the progress so far of the SNAPPY platform, as we've called it. The purpose of the SNAPPY platform is to provide simple, easy to use Python libraries for image-guided surgery. In image-guided surgery, you're typically doing things like having a tracker, a video source shown here. There's a laparoscope, and a computer system to put to combine everything together into some kind of system to guide a surgeon. So in this mock-up here, you can see this wonderfully white torso representing a human, inside of which we have a liver. And the general idea is that if we can align a CT scan to the liver, then we can show the surgeon this is what's inside the liver before you cut into it. This therefore provides what's known as augmented reality style of image guidance, where the surgeon can benefit from seeing the CT scan and the video at the same time. Now there's lots of algorithmic parts underneath that go into this. For example, scaling the video, the overlay correctly. To do that we need a process called camera calibration. We need to receive live tracking data from the trackers. We've got live video data. We may even have live ultrasound data. So the purpose of the platform is to bring all this together in a relatively simple way. It's not to provide the user interface. Typically the user interface is very specific to each project, so we would expect people using these libraries to do their own user interface. One of the things we noticed with previous projects in other computer languages such as C++ is that students typically don't do C++ anymore. So one of the main things is that it's all Python. So because so many students now are spending their life doing Python algorithms, specifically machine learning. So without going into too much detail, we now have all the components we need to do, live tracking, live imaging, blend it all together, do a decent augmented reality overlay and other types of display. And we can use this in a variety of computer-aided surgery systems. So in this example here, we're illustrating augmented reality overlay. So the reality is the video image, or what the surgeon sees, and we're going to augment it with a CT scan. So if we've aligned the CT scan to the video, the surgeon can insert the camera into our wonderful torso here through the hole, and then get a feel of where the internal structures might be inside the liver before they attempt or start the operation. So typically if we align to the surface of the liver, you don't need to see this liver model. So if I turn that off, I can now see the video of the liver, but I can also see a representation of the vessels that are within the liver overlaid on top of the video. And as I move the camera around, I can get a much better idea of where these vessels are inside the liver. Now this is just a simple phantom with one simple vessel inside it. Now in a human case, the vasculature is very complex. You'd also have typically tumours that you want to remove and critical vessels that you need to know where they are as you proceed through the operation. So in this lab demonstration, we're only showing you a sort of simple outline and a simple vessel structure, but the concepts and the principle is exactly the same. The system is tracking, it knows where the video camera is relative to the liver, and it then renders these vessels in the same position and overlays it. In addition to the demo that we've just seen downstairs, I'd like to give an overview of how we're using these SNAPPY libraries in a variety of different contexts within WISE. Firstly, when we came to publish, the SNAPPY libraries were renamed to Scikit Surgery, which was easier to find on the web and didn't clash with other libraries. So when I say SNAPPY or Scikit Surgery, it's the same thing. So there's a bunch of tutorials and examples, there's some documentation, all of which are useful for getting students underway and getting them to use these libraries. Now, as I said, we decided to make lots of small libraries. The upside is that each individual library is small and easy to use, and you can pick and choose. But the downside is there's a lot of them. So it can be a bit difficult to track or follow. So obviously we're always available for questions to get people started. But hopefully the documentation and all the examples are a great start in that area. So as we've seen, the Python libraries have been used in the SmartLiver project to deliver augmented reality for laparoscopic liver surgery. This has been used at the Royal Free. In addition, Jonathan SNAPPY has used some of this to develop a new skull-based navigation system which was used at the ION, and this work will continue. Jonathan's now at KCL, Tom Dowrick has a fellowship at UCL, and they will continue to develop this system in the coming months and years. In addition to this, the same libraries are used across some of our education. So we have a master's course where we have a module, Computer Assisted Surgery and Therapy, that's used on our biomedical engineering program, and now our new MSc in Medical Robotics and AI. The same libraries are used for demonstrations and projects at the CMIC Summer School, and all of this is available online to anyone who wants it at computerassistedsurgerycourse.net, which, while it's a bit of a mouthful, the notes are all there, and whilst we'd rather be teaching for real in the lab, a lot of this has now been written and revamped and reused during this pandemic era. So there's actually some great examples and tutorials that you can do from the comfort of your own home and get an appreciation of how these technologies work using common everyday household items and your mobile phone or laptop. So feel free to give these a go. In addition, also at home, Steve was developing some public engagement tools for home science, where he produced an augmented reality demo that ran on a Surface and taught some of the ideas of augmented reality using wooden building blocks and other stuff around the house. And we've also used these same libraries to do things like build ultrasound demonstrators for some of our public engagement work at Weiss. Particularly proud that actually what we set out to do was to make this stuff easier to use. So, for example, we had an MSc student who came to work with us for a summer project, and within that time she managed to integrate Google Voice Control into our SmartLiver system. And this, by having easy to use libraries in a language that people can rapidly get hold of, she was enabled to cover a lot more ground and get a much better educational experience. So within that summer, she was able to go through the whole software development life cycle, looking at requirements analysis, designing something, implementing it, integrating it in the system, and testing it with our surgeons, and producing a write-up and documenting the code, which gives a much more complete understanding of how these kind of things might work out in the real world. In addition, Steve has led an example where, a BSc project, Asta, she has implemented software to do glenoid version measurement, a topic I know almost nothing about. But the point is, though, that by having such framework and such readily available Python libraries, you can make a lot more progress within a short period of time. So credit to Steve and Asta specifically. They were able to develop some software, test it, and bring it actually to it's a SPI submission. So fingers crossed for that one, and hopefully that will also get published in due course. So as a summary, by using Python, which was a simple language that lots of people already know how to do, we're able to increase the amount of research we do. It's easy to do new algorithms. It's easy to integrate with existing libraries that people are already using, especially machine learning. It's easy to integrate with our teaching. It's easy to write examples, Jupyter notebooks, tutorials, and we can use the same code and the same libraries across our public engagement activities, our educational programs, and we're now moving into web applications. So I'll leave you there. I'll leave you the URL on the screen, and thank you very much, and I hope to see you all again soon.